Well, thank you very much for the kind introduction, and thank you very much for being here. My name is Philipp Brauner. I'm from Aachen University, and I'm here to talk about a project we did with a few colleagues, Julia von Heek, Martina, Ziefle, Hamdan, who's also here in the audience, and Jan Borchers. And my talk connects a bit to the panel discussion we had earlier this day on new surfaces we could use in human-computer interaction. First, I would like to briefly introduce my project. On the one hand, we see the ubiquitous computing segment with more powerful computing devices, smaller computing devices, and increasingly interconnected computing devices that can be integrated into everyday objects. We have controllable light bulbs in our homes, smart heating, etc. But when we look at our devices, they're usually made of plastic, glass, aluminum, and they are perceived as stiff and cold and also as artificial elements. And on the other hand, we have textiles, and humanity uses textiles for over 30,000 years, and textiles are perceived as warm, pleasurable, and they come in a variety of different forms, materials, functions, sizes, colors, you name it. And we wanted to combine both areas, and we did this in an interdisciplinary research project on interactive textiles called Ubiquitous. And in this project, we partnered with partners from academia and from industry to explore the possibilities of interactive textiles. We had three different areas of interest that we looked in. First, the so-called near field, that are textiles that are worn directly on the body, such as a jacket, for example. Then we looked at the extended areas that are textiles that we come in contact with, but when we move away, the textile stays there and they are not on our body itself. And an example is for an armchair, and I will report on this in the remainder of this talk. And we also have the surrounding space that are textiles that are in our home environment, such as curtains, for example. We have them, but we usually don't interact with them that often. And the research challenges we have is to realize a reliable gesture detection and the prevention of accidental activation, for example, and also to ensure discoverability of the gestures and easy learnability, and also high acceptance. That is, we don't want to build a fancy prototype, but we want to build products that are actually used by users. One early prototype we did was a smart jacket. I tell you about this very briefly. We integrated a patch with conductive yarn into the sleeve of a jacket, and users were able to perform different gestures. They could form a fold at different angles and at different sizes, and this could be used for media control, for example. And users stated that this interface is actually usable, but they found it not very useful, to be honest. Another prototype we realized was a smart curtain. In this case, conductive yarn is integrated into the curtain, and users could perform an opening and closing gesture. And this was the funniest student intern we ever had. And these were basically the functions of the curtain, so you could just open or close it. And again, we did a small user study, and the users attested a high discoverability of the gestures and also high learnability and high ease of use, but they reported a limited usefulness. This may be caused by the very, very small demonstrators that we have realized. So if you imagine a large house with large windows and a heavy, large curtain, then this might actually get useful. But now I come to the next area we looked into, textile interfaces for furnitures. And for this, we realized a textile interface for an armchair that was controllable by motors. So this armchair had an adjustable backrest and an adjustable footrest. And we realized different interfaces that we have evaluated in our study. So we had basically two types of interaction areas that you can also see and touch here. So the first was a bendable fold, like this. You could use this to activate the device. And the second was embroidered conductive yarn here that you can feel, and you can also use it eyes free. You just feel where the interaction area is. We had two different interaction modes, at least for the fold. So the fold can either be just touched to activate a movement of the motors of the armchair, or we had the actual fold that you had to fold this thing up or down to trigger the movement. And as already said, we linked this interface to the motors, but of course you can also imagine different types of controls, additional buttons, additional elements. So for example, you could control the light or the music in your home environment. Now the interesting question for our study was, first we wanted to also compare these novel interfaces with the traditional remote control. This was actually the remote control supplied by the manufacturer from the armchair. And we asked ourselves on which dimensions do we want to assess the quality of the novel interfaces. As you know, there are myriads of different evaluation criteria. Most studies focus on efficiency, effectivity, and user satisfaction from the old outdated ISO norm. But there are also different types of evaluation criteria that you can use. For example, you have this novel trend of user experience, which differentiates the evaluation of a product into the hedonic quality. Is it fun to use? Is it novel? Is it entertaining? And the pragmatic qualities. Is it efficient? Is the interaction dependable, for example? And there are also more formal models, such as the technology acceptance model, which aims at predicting the later adoption of a technology, and it does so by linking the actual use of a technology by the intention to use, which is usually highly correlated months or even years in advance. And the original TUM states that perceived usefulness and perceived ease of use are governing the actual usage intention. And in our study, we basically combined these expect, usage intention, hedonic quality, and pragmatic quality for evaluating the 4 different input modes of the armchair. We did so in a formal experiment, and the task for our subjects was very simple. They had to relax. After a stressing workday, they had to sit in the chair and find a comfortable position in the armchair by using this interface. We did not instruct how to use it. They had to discover it by themselves. And we assessed a number of different variables in the study, for example, age, gender, but also the attitude towards technology and the attitude towards textiles. And the order of the different interaction modes was randomized, of course, and we measured efficiency, perspectivity, dependability from the user experience questionnaire directly after interacting with the different interaction modes, and also the intention to use on a 6-point Likert scale. And then after the experiment, we did a summative questionnaire as well. And there we asked the novelty, stimulation, attractiveness of the armchair as a whole. And then we asked that the participants select one of the 4 interaction modes which they like most. So the sample of the study is as follows. We had 10 male, 10 female participants in the age range from 23 to 60 years. And it was a rather educated sample. I have a few more details presented in the paper. So, during the study and after the study, the participants had the opportunity to express their opinions, and have a few quotes for you. So, in regard to the conventional remote control, they said a rather positive statement. I'm used to the principle of a remote control. Of course, we all are. I've known it for years, and thus fast and efficient interaction is nothing surprising. And on the negative side, if this remote control falls down on the floor, for example, then the participants state, then you have to go up from the chair. If you imagine older people, this is really a big problem. And I totally agree, because they have to get up to control the chair. Now to textile interfaces in general. They say the shape and arrangement of the stitches imply how to control the chair. This is true if you look at this. It resembles the chair, and you have a direct mapping towards the chair. Regarding this interaction mode, touch the stitches, they say, I rather prefer this less visible design using only stitches and not a fold. Regarding the variant touching the fold, where you just have to touch it, they say, I don't understand it, what I have to do, should I bend it? And they were always a bit confused about this interaction technique, but they liked bend the fold more, and say, I really like that I can feel directly what I have to do. For me, it's obvious that I have to bend the fold up and down in order to operate the chair's footrest. Now I dive into the numbers from the experiment. We found a significant effect of the interaction mode on the pragmatic evaluation, that is efficiency, perspectivity, and dependability. And when we look at the ranking that emerges from this, the conventional remote control supplied by the chair, that was a bit ugly, was rated highest, and touching the fold was rated lowest, and bend the fold and touch the stitches were in between. So the old boring interface was rated highest. But now comes the interesting part. When we look at the intention to use, the variable that predicts the potential usage in the future, then bending the fold was rated highest, followed by touching the stitches, and then comes the plastic remote control, and then touching the fold. It gets even a bit clearer when we look at the forced choice. Then you see that touching the fold as a plastic remote control was only selected by 2 people each, and both other variants had 8 selections. So, despite the highest pragmatic evaluation, the conventional remote control was rated lowest in this study, and touching the fold is consistently rated low, so probably this is one interaction mode we probably will not look at any further. We also investigated some correlations between the different variables. We see limited influence of the different explanatory user variables we have captured. We only see that women reported the highest usage intention, that you can see here in this area, but we found no further effects from the user factors. However, it was a rather small sample, so with more participants, maybe some different patterns may emerge. When we look at the interconnections of the variables from the user experience questionnaire, we see that all scales from the pragmatic component are highly interconnected. This is the triangle up here. And the hedonic scale, the hedonic elevation, is not that clearly interconnected. However, each dimension is positively linked to the intention to use. So if we focus on one dimension and increase it, then the overall intention to use this product will probably increase. What we did then in the final step was we wanted to learn what is decisive for the intention to use, what is the most important factor that we need to address to increase the intention to use this product. We calculated a multiple linear regression for this, and we were able to explain about 50% of the variance in intention to use, and the single predicting factor was attractiveness. So the overall attractiveness is the key predictor for the acceptance of this novel input technique. This basically concludes my talk. What have we learned? First, we have seen that the integration of smart interactive textiles and furniture is possible. Whoa, what a finding. And we have also seen that the textile interfaces were preferred over the original remote control supplied by the manufacturer, despite the higher pragmatic qualities of the remote control. And we learned that the overall user experience and acceptance is mostly determined by the chromatic hedonic properties, such as attractiveness of the overall product. Now we come to the limitations of the study. As I said, the sample was quite small, just 20 participants, and also we had a rather limited input and control space. So basically, the armchair could go up or down with the back or with the footrest. And a part of our evaluation was for the whole product and not for each individual input modality we provided. So far my talk. Thank you very much. I'm here for questions.
Thanks a lot. We have time for questions, so anyone interested?
Hi, it's Raimund again. Interactive media electricity. So interesting work, and I was just thinking a little bit about whether there is some condition in between the remote control and your creases. So I remember Mercedes-Benz has introduced some 20 years ago some knobs in their doors, in their car doors, where they have buttons exactly for the same control of controlling the seat which were arranged like your creases, you know that perhaps?
Not exactly, but
so,
you mean
could
a
it
direct
look-
mapping?
so they really look exactly like a miniaturized seat, and you can control them. This really beautiful piece of work. And so maybe you could have thought about having something like that, so something more three-dimensional and more graspable, so a kind of bigger version of these creases on the side, but still having this texture of your textiles. So did you think about this? Something in between, so something with more affordances, but still being integrated into this furniture?
Yeah, I think this is a very good point, and we are basically at the starting point in textile interface. We can do so many things with this, and our subjects reported that they either like this variant or this variant. So I don't know if there's a single solution that fits all, but I think we have to build several variants for this. Thank you.
So,
No, I just wanted to escape.
yeah, so, I mean, I'm going to pitch this question a bit with my tongue in the cheek, all that, but, so when you're comparing against the remote control, which is the one the manufacturer provides, and, you know, I'll have really a problem, but while you were designing your textile, you were taking into account, like, the shape of the chair. That makes it like a lot more discoverable and all that. Yeah. But the way the buttons are arranged is not really that intuitive. I can imagine a user just going there and checking, what is that one? Is this or is that one the one? So I was wondering how much that could have affected.
So it was rather easy to learn for the participants. We didn't instruct them. They just had to sit in the chair and they were asked to use it, and they basically discovered the functioning of the interface by themselves. It was a bit more difficult for this variant with touching the fold, because then you have clear affordance to do something with the fold, but you aren't supposed to do something with it. So this was confusing for the participants, but both other variants, this on the left-hand side, were actually pretty easy to discover by them.
Okay. Thanks a lot.
Thank you.